Hello everyone, today we will solve physics Cambridge paper dated February-March 2022. Moving on to question number 1. The point in figure 1.1 represents a point mass. On figure 1.1, draw lines to represent the gravitational field around P. As gravitational field is attractive, which shows the attraction of the gravitational field. So all the field lines are towards the point P. B says, a moon is in a circular orbit around a planet. Explain why the path of the moon is circular. Obviously, we know that when an object moves in a circular path, this is because of centripetal force, and there is some connection between center and an object, which keeps it to move in a circular path. So here, gravity of Earth keeps the moon to move in a circular path. Assume this is the Earth, and this is the path the moon moves in. So the gravitational force of Earth provides the necessary centripetal force to keep the moon in a circular path. Also remember that the magnitude of velocity for a body moving in a circular path always remains constant, but the direction changes constantly. Another point which I can describe here is that velocity and acceleration, which is actually the centripetal acceleration, they are perpendicular to each other. So the centripetal acceleration is towards the center and the velocity is along the tangent. So velocity is perpendicular to centripetal acceleration. This point can also be written in this question. Part C says many moons are in a circular orbit around a planet. The angular velocity of a moon is omega when the orbit of the moon has radius r about the planet. The figure shows variation of r cube with 1 upon omega square for these moons. The graph is drawn between r cube upon 10 power 23 m cube and 1 upon omega square, which is actually the angular velocity of the moon, into 10 power 7 per radian square into second square. The unit for angular velocity is radian per second, but when we take 1 over omega, it becomes radian per square and second square. Part 1 says show that the mass of the planet is given by the expression m is equal to gradient upon g, where g is the gravitational constant. As the moon is revolving around the earth, there will be two forces, centripetal force and gravitational force. Centripetal force will be equal to mv square upon r. Gravitational force will be equal to gmm over r square. So here m will be cancelled out by m. By using v equals to r omega, we will substitute the value in place of v square. We will get r square into omega square upon r is equal to g capital M upon r square. So we will cancel r with r square and we'll move it to the other side. We will get r cube omega square equals g capital M. We have to get the formula in the question. So m equals r cube and omega square over g. So r cube omega square is now gradient. So m equals to gradient over g. Part 2 says use figure 1.1 and the expression in C part 1 to show that the mass of the planet is 1 into 10 power 26 kg. Using the expression from last question, m is equal to gradient upon g. As we know, the value of capital G is 6.67 into 10 power minus 11 Newton meter square per kilogram square. Now we need to find the value of the gradient. Gradient is actually y by x. It's a ratio of vertical over horizontal. So from graph we can get these values in a very simple way. This point connects to this point. Vertical axes join the point. This point connects to this point. So we can take any values, but for the sake of simplicity, we're taking whole values. So this will be 4.1 and this will be 6. So y here will be equal to 4.1 into 10 power 23, and x here will be equal to 6 into 10 power 7. These are the two values that we will use in our formula. So mass will be equal to the value of y, 4.1 into 10 power 23, upon the value of x, 6 into 10 power 7. And we divide this whole value by the value of capital G, which is 6.67 into 10 power minus 11. By sorting all of these values, we get 1 into 10 power 26 kg. Moving on to the next question, it says determine the speed of a moon in orbit around the planet with orbital radius of 1.2 into 10 power 8 meters. Again, it will be calculated by centripetal force equals gravitational force. So this will be mv square upon r is equal to gmm upon r square. R will be cancelled here, and v square is equal to gm. We also cancel m here upon r. Now putting the values of these three quantities, v equals under root 6.67 into 10 power minus 11 into, we found that m is equal to 10 power 26, which is divided by r, which is given here. It is 1.2 into 10 power 8 meters. Simplified using a calculator, we get 5.6 into 10 power 7. This is the value for v square. Exact value for v will be 7500. The next question says a fixed mass of an ideal gas has volume v and a pressure p. The gas undergoes a cycle of changes x to y to z to x as shown in the figure 2.1. So this is a cyclic process. The system comes back to the initial stage. So the change in internal energy is 0. Its temperature remains same. Part A says state the change in internal energy for one complete cycle. As I described earlier, it is a cyclic process, so the internal energy change will be 0. B says calculate the N amount of gas, so we will use PV is equal to nRT. N equals PV upon RT. Putting the values of P, we can get these values. So 1.5 into 10 power 5 into volume. For volume, it is 4.2 into 10 power minus 3. Dividing it by 8.31 into 540. By using a calculator, we get 0.14 mole. Next part says complete the table, use the space below for any working. So if we find the volume of Z first, then the other two quantities of Y will be easier to find. So let's use the relation P1 V1 upon T is equal to P2 V2 upon T. I can also use T1 and T2. This is because PV equals to nRT and PV upon T is equal to nR. The product of pressure and volume divided by temperature is equal to nR, which is a constant. As I only need to find Vz here, I will use Px Vx upon Tx and consider this Pz Vz upon Tz. So we have to find Vz here. Vz will be equal to Px Vx upon Tx into Tz upon Pz. Putting values 1.5 into 10 power 5 into 4.2 into 10 power minus 3 upon 540 into 782 upon 5.1. By using a calculator, we get 1.8 into 10 power minus 3, which will be the value of Vz. Here we will write 1.8 as the value of power is written on top. Let's find the remaining values. If we look at Z and Y, they're the same point at x-axis, which means that the value of volume for Y and Z are same. For X and Y, the value of pressure is same. So we will write 1.5 here, and we will write 1.8 here. Question D says the first law of thermodynamics may be represented by the equation delta U Q plus W. State with reference to the system what is meant by. Note that all of these quantities are positive. Delta U means increase in internal energy. Q means internal heat supply. W means work done by the system. The second point is actually heat absorbed. For negatives, we will say decrease in internal energy, heat dissipated, and work done on the system. Part 2 says explain how the first law of thermodynamics applies to the change Z to X. From this point to this point, we see that volume of the system is increasing. If volume is increasing, it means that the temperature is decreasing, and internal energy of the system is decreasing as well. Volume of the system increases, temperature of the system which decreases the internal energy, work done by the system.